Hello everyone, welcome to IB Math Solution. Today we are going to continue sequences and series chapter, and we are going to study arithmetic sequences, or also called arithmetic progression. So let's consider this sequence, that is 4, 7, 10, 13, 16, 19, 22 and so on. Is there a common pattern here? Yes, we can see that. Second term, that is 7, is 3 more than 4. So second term is 3 more than the first term. Third term is 3 more than the second term. So we can simply say there is a difference d of positive 3. If we subtract first term from the second term, that is 7 minus 4, we get positive 3. If we subtract the second term from the third term, that is 10 minus 7, we get positive 3 again. And so on. If we subtract 10 from 13, that is 13 minus 10, we again get positive 3, and so on. 16 minus 13 is positive 3, 19 minus 16 is positive 3, 22 minus 19 is also positive 3, and so on. This series goes on. This positive 3 in each step is called difference. We denote it with letter D. It is also called common difference. So from here we can see common difference that equals D can be written as u2 minus u1, u2 minus u1. It can also be written as u3 minus u2, that is u3 minus u2. And it can also be written as u4 minus u3, that is u4 13 minus u3 10. So in general we can say D equals un plus 1 minus un, and this can be considered as the formula for common difference. Now, the sequence in which we have a constant common difference throughout the series, throughout the sequence, that sequence is called arithmetic sequence or arithmetic progression. So here's the definition for the same: a sequence where the difference between two consecutive terms is always same. That sequence is called arithmetic sequence or arithmetic progression. Now let's see the general form of arithmetic progression. So from here on, we'll write arithmetic progression as AP. So the general form of AP is U1, U2, U3, U4, U5, U6, where U1 is U1, U2 is U1 plus difference, U1 plus D. U3 is U2 plus difference, so U2 is U1 plus D. And if we add another D to it, this becomes 2D. So this will be U1 plus 2D. Similarly, U4 becomes U1 plus 3D. U5 becomes U1 plus 4D. U6 becomes U1 plus 5D, and so on. So if we consider this generalization, we can simply say the nth term of this arithmetic progression AP, that equals un or tn or capital Tn or capital An, can be written as u1 plus n minus 1 times d. So considering u6, if n is 6, then we have 5 multiplied with d. What is 5? 5 is 6 minus 1, that is n minus 1 here. So sixth term can be written as u1 plus 5d. Therefore, nth term can be written as u1 plus n minus 1 times d. And that is what we have written here. The nth term un is written as u1 plus n minus 1 times d. And this can be considered as the formula for nth term, or un or tn. Here we know u1 is the first term of the sequence and d is the common difference. This common difference is the same common difference for which we have just come up with the formula here. Now let's get started with solving some problems from exercise 5B. Decide whether these sequences are arithmetic or not. So as usual, I'll solve The problems circled in blue, the ones circled in red are for you to solve on your own. See, so this is 41, 35, 29, 23, 17, and so on. This is U1, this is U2, this is U3, this is U4, this is U5. Now to check whether these terms together form an arithmetic series, what we need to do is we need to find U2 minus U1, that is 35 minus 41, and it equals -6. Then we need to calculate U3 minus U2. U3 is 29, U2 is 35. This again equals -6. Then we need to calculate U4 minus U3. U4 is 23, U3 is 29. This again comes out to be -6. Now U5 minus U4. U5 is 17 minus U4 is 23. This again comes out to be 6. As we can see, this difference is same throughout. Therefore, we can say this sequence is arithmetic. In case this difference is not same throughout, then this sequence will not be considered arithmetic. Take the first term u1 and common difference d for these arithmetic sequences. So we already know these sequences are arithmetic. In that case, the common difference between each consecutive term is always the same. So u1 is -4 and d is u2 minus u1. u2 is 3, u1 is -4. So this becomes 3 plus 4, that is 7. That's the answer. Let's go to the next question. For each arithmetic sequences, state u1 and d. So see, u1 is 8, d is u2 minus u1, that is 9.5 minus 8, that becomes 1.5. Find the formula for the general term un. So the general term un is going to be u1 plus n minus 1 times d. That is going to be 8, u1 is equal to 8 plus n minus 1 times d. d is 1.5, or we can simply write this as 3/2. So here d is 3/2. So we can simply write it as 8 plus n times 3/2 minus 3/2. And if we solve it, we get 8 minus 3/2 plus 3n/2. Solving it further, we get 16 minus 3, that is 13/2 plus 3n/2, or 13 plus 3n/2. This is the formula for general term. Find the 15th term of the sequence. So 15th term, u15, is going to be 13 plus 3 times 15 divided by 2. That is going to be 13 plus 45 divided by 2. This is 58 by 2, and that is 29. F. So state u1 and d. So for f, u1 is u1 equals a and d equals u2 minus u1. u2 is a plus d minus u1 is a. So we know this a cancels this one, and what remains is d. So common difference d equals d. To find the formula for the general term un. So general term un is going to be u1 plus n minus 1 times d. So we know u1 is a plus n minus 1 and d is equal to d. So this is the formula for general term. Find the 15th term. So u15 is going to be a plus 14d. That's the answer. Let's go to the next question. Consider the sequence 6, 17, 28, 39, 50. Show that the sequence is arithmetic. So to show whether the sequence is arithmetic or not, we need to find the difference between every consecutive term. And if that difference is same throughout, then we can say that the sequence is arithmetic. So u2 minus u1 is 17 minus 6, 11. u3 minus u2 is 28 minus 17, that is 11. u4 minus u3 equals 39 minus 28, and that is 11. u5 minus u4 is 50 minus 39, and that is 11. So as the difference is same throughout, therefore the sequence is arithmetic. B. Find the formula for its general term. So un is going to be u1 plus n minus 1 times d. u1 is 6 plus n minus 1 times d. We know what we have calculated here is d. So d is 11. So we can simply substitute the value of d here. So this becomes 6 plus 11n minus 11, or we can say 11n minus 5. So un is 11n minus 5. That's the answer. C. Find the 50th term. So u50 is going to be 11 times 50 minus 5. That is 550 minus 5, or 545. Is 325 a member? So let's check. Let's say some term, let's say nth term is 325. What is the formula for un? It is 11n minus 5. This equals 325. We can say 11n equals 325 plus 5, that is 330. Or we can say n equals 330 divided by 11, that is 30. Now we can say since n comes out to be an integer, therefore 325 is a member. Had this n not been an integer, had this n been a decimal number or a rational number, we would have easily known that 325 is not a member. So in this case, as n is an integer, 325 is a member of this sequence. Is 761 a member? So let's do the same for 761. Un equals 761. If we substitute the formula, we get 11n minus 5 equals 761, and 11n equals 761 plus 5, that is 766. Now n equals 766 divided by 11. If we calculate it, 766 divided by 11, we get 69.63. Here we can say, as n is not an integer, therefore we can say 761 is not a member of the sequence. Let's go to the next question. Now this type of problem we have just solved in the previous one, so I'll skip this one. This is for you to do on your own. A sequence is defined by un equals 3n minus 2. But by finding un plus 1 minus un, prove that the sequence is arithmetic. So un plus 1 is going to be 3n plus 1 minus 2. That is 3n plus 3 minus 2, or simply 3n plus 1. And un is 3n minus 2. If we take difference, un plus 1 minus un, we get 3n plus 1 minus 3n minus 2. Now solving it, we get 3n plus 1 minus 3n plus 2. From here we can see that this 3n will cancel this 3n, negative 3n, and we are left with 3 only. Now this 3 is a constant. What do I mean by constant? This 3 doesn't change with the nth term. Let's say if I have 100th term or I have 50th term, this 3 won't change because this equation doesn't have n in it. It has a constant number. Therefore, when we have a constant, we can simply say, since the difference is a constant, therefore the sequence is arithmetic. B. Find u1 and d. u1 equals 3 times 1 minus 2, that is 1. And d, we have just calculated here, un plus 1 minus un. d equals 3. C. Find the 57th term. So u57 equals 3 times 57 minus 2. So 3 times 57 is 171, and 171 minus 2 is 169. That's the answer. What is the largest term of the sequence that is smaller than 450? Which term is this? So the largest term less than 450, we have to find that term first, and then we need to calculate the value of n. So we know un is u1 plus n minus 1 times d, and that should be less than 450. u1 is 1, n minus 1, d is 3. This should be less than 450. So if we subtract 3 from both sides, we get n minus 1 times 3 here and 449 on the right hand side. If we divide both sides by 3, we get n minus 1 less than 449 divided by 3. Now 449 divided by 3 equals 149.66. So n minus 1 is less than 149.66. And if we add 1 on both sides, we get n should be less than 150.66. And the value of n can never be in decimal form. It has to be an integer because we cannot have 150.66th term. We can have either 150th term or we can have 151st term. We cannot have a term in between. Therefore, now n has to be less than this number and an integer. Therefore, the value of n is 150. 150 is less than this number and is also an integer. Now this is the term less than 450 is 150th term. Now it is also asking us the largest term. We have calculated this. Which term is this? This is 150th term. Now the largest term u150 is going to be 1 plus 150 minus 1 times 3. That is 1 plus 149 times 3. If we calculate 149 times 3, this is 447, and plus 1, 448. So this term, so 150th term is 448. That's the answer. Let's go to the next question. A sequence is defined by this expression. Prove that the sequence is arithmetic. So we have done it many times. We'll first find u2 and then find u1, and then subtract u1 from u2. For what values of n are the terms of the sequence less than? We have also done this just now. Let's go to the next question. Consider the arithmetic series. Find u1 and d. So this is for you to do. Which term of the sequence is negative 30? An arithmetic sequence starts 23, 36, 49, 62. Find the first term of the sequence to exceed 100,000. So we know u1 is 23. D is 36 minus 23. That is 13. Now the question is asking us the first term un that exceeds 100,000. The formula for un is u1 plus n minus 1 times d. It should be greater than 100,000. u1 is 23 plus n minus 1 times d. D is 13. Should be greater than 100,000. Now n minus 1 times 13 should be greater than 100,000 minus 23. That is going to be 99,977. N minus 1 should be greater than 99,977 divided by 13. If we calculate this, 99977 divided by 13, we get n minus 1 should be greater than 7690.53. So n should be greater than 7691.53. Now we know n has to be an integer, and that integer has to be greater than this. So n is 7692. So 7692nd term of this sequence is going to be greater than 100,000. That's the answer. Let's go to the next question. A sequence is defined by the formula u1 equals negative 12, un plus 1 equals un plus 7, and n is always greater than or equal to 1. Prove that the sequence is arithmetic. We know un plus 1 equals un plus 7. So from here we can say un plus 1 minus un equals 7. We know this is the formula for common difference d, and d is 7, that is a constant. Therefore, we can say the sequence is arithmetic. Find the 200th term of the sequence. We know un equals u1 plus n minus 1 times d. u200 is going to be u1, that is negative 12, plus the value of n is 200. 200 minus 1 is 199, and d is 7 from here. So we can say 199 times 7 equals 1393. So this number is going to be 1393 minus 12, that is 1381. C. Is 1000 a member of the sequence? So un equals u1 plus n minus 1 times d. Now we know the value of un is 1000, u1 is negative 12, n minus 1 times d. D is 7. So this is going to be 1012 equals n minus 1 times 7. 1012 divided by 7 equals n minus 1. So 1012 divided by 7 equals 144.57. 144.57 equals n minus 1, or simply the value of n is 145.57. Now we can say, since n is not an integer, therefore 1000 is not a member of the sequence. Let's go to the next question. What can you say about u1 and d for an arithmetic sequence if all of the terms are even? So let's say this sequence is going to be 0, 2, 4, 6, 8, 10, 12, and so on. All terms are even. So what we can say is u1 is 0 and d is 2. Similarly, all of the terms are odd. So if all of the terms are odd, the sequence is going to be 1, 3, 5, 7, 9, 11, 13, and so on. And in this case, u1 is going to be 1 and d is going to be 2. That's the answer. Let's go to the next question. Find k given the consecutive arithmetic terms. So we know this term, and this term, they all are consecutive. So we can say if this is the third term, this will be the fourth term, this will be the fifth term. Or if this is 10th term, this will be the 11th term, and this will be the 12th term. So they are consecutive. In that case, can we say that this number minus this number will always be equal to this number minus this number? Or simply we can say d is going to be negative 2 minus k minus 2k plus 18. and d is also going to be 2k plus 2, 2k plus 2 minus negative 2 minus k. So and we know this d is going to be same for an arithmetic series. Solving this, we get negative 2 minus k minus 2k minus 18. And solving it further, we get negative 20 minus 3k. Solving this equation, we get 2k plus 2 minus, and this minus with the negative sign will become positive 2 plus k. Solving it further, we get 4 plus 3k. Now we know this d equals this d. Therefore, negative 20 minus 3k equals 4 plus 3k. Taking this negative 3k over to the right hand side, we get 3 plus 3, that is 6k. And this 4 over to the left side, we get negative 20 minus 4, that is negative 24. And hence 6k equals negative 24, or k equals negative 24 by 6, that is negative 4. So k equals negative 4 for this sequence. Similarly h. So we know k minus 5 must be equal to k square minus 8 minus k, because they both mean the common difference. In this case, k minus 5 equals k square minus k minus 8. Taking everything onto the right hand side, we get k square minus k minus k minus 8 plus 5 equals 0. So k square minus 2k minus 3 equals 0. Now we can simply write it k minus 3 times k plus 1 equals 0. So from here we can say k minus 3 is 0, or k plus 1 is 0. Here k equals 3, here k equals negative 1. So we have two values of k equals 3 or negative 1. That's the answer. Let's go to the next question. Find the general term un for an arithmetic sequence with u7, we know is going to be u1 plus 6d, and it is equal to 41. u13, we know this should be equal to u1 plus 12d, and this is equal to 77. Now this is equation 1, this is equation 2. If we subtract the first equation from the second, we get u1 plus 12d equals 77, u1 plus 6d equals 41. Negative, negative, negative. This u1 minus u1 is 0. This 12d minus 6d is 6d, and 77 minus 41 equals 36. Therefore, d equals 6. Now substituting this value of d in equation 1, we get u1 plus 6 times d equals 41. So u1 equals 41 minus 36, that is 5. So we can say u1 is 5. Substituting d in equation 1. So from here we can say un equals u1, that is 5, plus n minus 1 times d. D is 6. And this becomes 5 plus 6n minus 6. that equals 6n minus 1. So un equals 6n minus 1. This is the general term. Now this is for you to do on your own. They all are same kind of questions. So these are for you to do on your own. I have done this. I'll go to the next question. Insert three numbers between 5 and 10. So we know we have 5 and we have 10. So that all 5 numbers are in arithmetic sequence. So whatever this term is, this can be first term, this can be second term, this can be third term, this can be 100th term, we don't know. What we know is that the very next term is going to be 5 plus d, and the following terms are going to be 5 plus 2d and 5 plus 3d. We have inserted three numbers here between 5 and 10. We can simply say this 10 is going to be equal to 5 plus 4d. So can we say that 10 equals 5 plus 4d? 5 equals 4d and d equals 5 by 4. Now we know the value of d, so we can find out the values of these three terms. This 5 plus d is 5 plus 5 by 4. That is going to be 25 by 4. 5 plus 2d is going to be 5 plus 5 by 4 times 2, and that is going to be 5 plus 5 by 2, and this is 15 by 2. So this is first number, this is second number, and third number is going to be 5 plus 3d, that is 5 plus 3 times 5 by 4. This is 5 plus 15 by 4, 35 by 4. So these are the three numbers that we insert between 5 and 10. Let's go to the next question. Insert 6 numbers between -1 and 32 so that all 8 numbers are in arithmetic sequence. So we'll again do the same. What we'll do is we'll write -1 and we'll write 32. And what we have to do is -1 plus d, -1 plus 2d, -1 plus 3d, -1 plus 4d, -1 plus 5d, -1 plus 6d, -1 plus 7d, -1 plus 8d. Now these are the 8 numbers. So we can definitely say this is going to be -1 plus 9d. If we solve it, -1 plus 9d equals 32. We can say 9d equals 33 and d equals 33 by 9 or 11 by 3. Now the value of d is 11 by 3. Substituting this value of d in each of these terms, we get the values of these terms. The part from here is very easy. Do it on your own. I'll go to the next question. Insert three numbers between 50 and 44 so that all 5 numbers are in arithmetic sequence. So this is for you to do on your own. Very easy, just like previous questions. Assuming the sequence continues, find the first negative term of the sequence. So this is also we have done many times. A luxury car manufacturer sets up a factory for a new model vehicle. In the first month, only 5 cars are made. After this, 13 cars are made every month. List the total number of cars that have been made by the end of each of the first 6 months. So let's say this is the end of first month, this is the end of second month, third month, fourth month, fifth month, and sixth month. So by the end of first month, we have 5 cars made. By the end of second month, we have 5 plus 13 cars. By the end of third month, we have 5 plus 2 times 13, 5 plus 3 times 13, 5 plus 4 times 13, 5 plus 5 times 13. So we can say this is 5, this is 18, this is 31, this is 44, this is 57, and this is 70. List the total number of cars that have been made by the end of each of the first 6 months. So we have done part A. Explain why the total number of cars made after n months form an arithmetic sequence. Since the number of cars made each month is constant, and what that constant is, it is 13. Therefore, we can say that the total number of cars made after n months forms an arithmetic sequence AS. How many cars are made in the first year? So we know we have 12 months in a year. And for 12 months, first month we have 5 cars and then 13 cars each month. So only 11 months are left. So 11 will multiply with 13. And that is going to be 5 plus 143. That is 148 cars. How long is it until the 250th car is made? So we know un equals 250. Therefore, un is u1 plus n minus 1 times d equals 250. Now the value of u1 is 5, n minus 1 times d is 13, 250. So n minus 1 times 13 equals 250 divided 250 minus 5, that is 245. And n minus 1 equals 245 by 13, that is 245 by 13 is 18.84. 18.84. So n equals 19.84. This n is the number of months. Now the question is asking how long is it until the 250th car is made. So 250th car is going to be made in the 20th month. 20th month, because 19 months have already passed and it is over and above 19 months. That is going to be the 20th month. Let's go to the next question. At the start of the dry season, Yafia's 3000 liter water tank is full. She uses 183 liters of water each week to water her garden. Find the amount of water left in the tank after 1, 2, 3, and 4 weeks. So after week 1, we'll be left with 3000 minus 183. That is 2817 liters of water. After week 2, we'll be left with 2817 minus 183. That is going to be 2817 minus 183. 2631. 2631 liters of water. And so on. The others are for you to do on your own. I'll explain why the amount of water left in the tank after n weeks forms an arithmetic sequence, since water used each week is constant, that is 183 liters. Therefore, we can say that the amount of water left in the tank after n weeks forms an arithmetic sequence. The same thing. When will Yafia's tank run out of water? So this is for you to do on your own. This is very easy. So let's go to exercise 5B.2 and solve its questions. Helena is measuring the mass of oranges on a scale. When there are 8 oranges, the total mass is 1.126 kilograms. So mass of 8 oranges 1.126 kg. So mass of 1 orange is going to be 1.126 divided by 8 kg, and that is going to be 0.141 kg, or simply 141 grams. So find the average mass of the oranges on the scale. So this is what we have already calculated. This is the average mass. B. Hence, write an arithmetic sequence for un, the approximate total mass when n oranges have been placed on the scale. So we know un equals u1 plus n minus 1 times d. So u1 is the mass when first orange is placed on the scale, and we know the mass of one orange is 141 grams, so u1 is 141. This is n minus 1, and we know the next orange that we are going to place on the scale is also of 141 grams. Therefore, the difference is going to be 141. In this case, if we solve this equation, we get 141 plus 141n minus 141. This 141 cancels this 141, and we get 141n. This is the general equation. That's the answer. Nade has placed an empty egg carton on a set of scales. Its mass is 32 grams. When the carton is filled with 12 eggs, the total mass of the eggs and carton is 743 grams. We know the mass of an empty carton is 32 grams. And we know the mass of carton plus 12 eggs is 743 grams. Can we say the mass of 12 eggs is going to be 743 minus 32 grams, and that is going to be 743 minus 32, 711. So 711 grams. Can we say mass of one egg is going to be 711 divided by 12 grams? That is 59.25 grams. Find the average mass of the eggs in the carton. So this is the average mass. Hence, write an arithmetic sequence for un, the approximate total mass when n eggs have been added to the carton. So we can say when there is no egg, the weight of the carton is 32 grams. And when there is one egg, the weight increases by this much one times. So 59.25. And when we have n eggs, the weight will increase by this multiplied by n. So this is going to be the weight with n eggs in the tray. For what values of n is your model valid? So we know n is the number of eggs, and it has to be greater than or equal to 0 and less than or equal to 12, because a carton can hold only 12 eggs. That's the answer. Let's go to the next question. A farmer has 580 square bales of hay in his shed with total mass 9850 kg. The farm has 8 yards of animals. Each day, the farmer feeds out 2 bales of hay to each yard. So, write an arithmetic sequence for the number of bales of hay remaining after n days. So, each day, can we say the farmer is feeding out 8 times 2 bales of hay? So, each day, the farmer is feeding out 2 times 8, that is 16 hay bales. So can we say after each day there is going to be 16 less hay bales from 580? So after n days we can say un is going to be 580 minus 16n. This is the answer. Write an arithmetic sequence which approximate the mass of hay remaining after n days. So we know average mass equals 9850 divided by 580 kg, and we know he is feeding out 16 hay bales every day. Therefore, mass being fed out is 16 times 9850 divided by 580 kg. Therefore, the remaining mass after n days, this is the mass being fed out each day. Therefore, the mass remaining after n days is going to be un equals 9850 minus this times n, where n is the number of days. Now you can solve it further to get the exact answer. I'll go to the next question. Valeria joins a social networking website. After 1 week, she has 34 online friends, and after 9 weeks, she has 80 online friends. Find the average number of online friends Valeria has made each week from week 1 to week 9. So after 1 week, she has 34, and after 9 weeks, she has 80. So what's the difference? Average is going to be 80 minus 34 divided by 9 minus 1. That is going to be 46 divided by 8, or 23 divided by 4. Assuming that her total number of online friends after n weeks forms an arithmetic sequence, find a model which approximates the number of online friends after n weeks. So we know u1 equals 34 and difference d equals 23 divided by 4. Therefore, un equals u1, that is 34, plus n minus 1 times d. that is 23 divided by 4. So this is the answer. Do you think it is a problem that the common difference in your model is not an integer? Explain your answer. No, it is not a problem because common difference D here indicates the average number of friends gained each week. It is used for approximation only. Whenever we need to show the number of friends, we can always show it in whole numbers. Use your model to predict how many online friends Valeria will have after 20 weeks. So Valeria will have after 20 weeks about 34 plus 19 times 23 divided by 4. So this is going to be 34 plus 19 times 23 divided by 4. Valeria will have about 143 friends. That's the answer. Let's go to the next question. A wedding reception venue advertises all inclusive venue hire and catering costs of 6950 euros for 50 guests or 11,950 euros for 100 guests. Assume that the cost of venue hire and catering for n guests forms an arithmetic sequence. Write a formula for the general term un of the sequence. So we know u100 is u1 plus 99d and it is equal to 11,950. We also know u50 equals u1 plus 49d and this equals 6950. This is equation 1, this is equation 2. Now if we subtract equation 2 from equation 1, we can say negative sign, negative sign, negative sign, and this u1 will cancel this u1 and will be left with 50d equals 11,950 minus 6,950, 5,000 euros, and d equals 5,000 divided by 50. So this is going to be 100. So d equals 100 euros per person. Now substituting d into equation 2, we get u1 plus 49d equals 6950. So u1 is going to be 6950 minus 4900 and that equals 2050 euros. Therefore, the general equation equals u1 plus n minus 1 times d and that is equal to 2050 plus n minus 1 times 100, that is 2050 plus 100n minus 100, simply 1950 plus 100n. This is the answer. Explain the significance of the common difference. So common difference d is the increase in cost for every person or every guest. The constant term U1 is the cost of venue hire. Estimate the cost of venue hire and catering for a reception with 85 guests. So U85 is going to be 1950 plus 100n. The value of n is 85. Now this is for you to solve on your own. I'll see you in the next session.